More, we now have everything good? All right, I heard a robot voice, but so yeah, JavaScript applications became more and more complicated. We have WASM. We've got essentially binaries now running on the browser. The browser is now a fundamental part of our security of our applications. So I thought it might be good for us to talk a little bit about the browser. How many people have thought about browser security? Okay, couple. That's good. What is your just kind of impression? Safe or not safe on that scale? Not safe. All right, so. Okay, all right. So we're going to be having this discussion and just kind of see, is it safe, is it not, etc. So one more time, my name is Jerry, Chief Security Strategist at a company called SquareX, SQRX.com. So just a little bit about me. I've been in OWASP since 2008. That was a long time ago. I've been a lifetime member since 2010, so I can attest it's great to be a lifetime member. I've done a lot of roles in security. I've been a developer, a strategist, a consultant, an architect, a trainer, an entrepreneur, et cetera, mainly focus on application security. Yeah, I've done all these different roles, and I've had a great time. So let's talk about browsers. I'm going to make the statement here that browser security is really the next battlefield. So we talk about, up until now, we like to talk about application security and code level security and things like that. We know that kind of our, the other half of that equation has always been the endpoint, right? And is the endpoint secure, even if it's hosting our web applications, et cetera. But you're going to find out very quickly that browsers are the new endpoint. So when we talk about endpoint security, when we talk about operating system security, it's really kind of coming down to that browser. If you think about it, the browser is the ultimate application, right? That's what we use to access all sorts of, goodies on the web, which we're going to get into in just a moment. And the point that I'm going to make is that the browsers sit in between two different security controls. Right? Let's think about you, right? You have your laptop, you've got a browser. Hopefully, if you're depending on the company you work in, you have some endpoint protection, right? EDR, XDR on the endpoint. And then what helps you, the security that you get from your organization is a secure web gateway. And it blocks you from downloading malware, and it blocks you from getting into bad websites. The point I'm going to make is this is very similar to the way application security used to be, where people would tell you, oh, yeah, we don't worry about application security. We have a firewall. Or, yeah, we've got a WAF. We're good. We knew in the AppSec community that the security has to go into the code. And what you're going to find out is the browser is going to go through that same evolution where security needs to go into the browser. Right now it's external, and that's unfortunate. You're going to see why in just a moment. So far, so good? Okay, feel free to ask questions at any time, just so you know. So obviously, browsers are absolutely unbelievable. I was making a video the other day, and I was editing it all in the browser, right, on Canva, which is something that, think about the early days of browsers you couldn't even think of. So you've got all of your Office suites. So you've got, whether you use Google or use Microsoft, you do it sometimes through a browser, right? Video editing, gaming, live conferences, you can do this Zoom call through a browser. And so what happens is the more stuff the browser can do, the more technologies we add onto it. So we've got like WebAssembly, we've got HTML5, that gives us a whole bunch of APIs, right? Like geolocation and turning on the microphone, turning on the camera, things like that. We've got WebRTC file APIs, all sorts of things that traditionally we don't think that browsers can do, but they can do. They're no longer just viewers. They're not just very dumb terminals like they used to be, where they would just show you some HTML, CSS, and a little bit of JavaScript form validation. They are now complete application platforms. So just like Spider-Man said, right, with more power comes more responsibility, right? In this case, more power equals larger attack surface. Yeah. So as I mentioned before, this is something that maybe you've thought about or maybe you haven't, but if you're thinking, well, I've got my endpoint security on my laptop, I've got CrowdStrike, I've got whatever, aren't they going to help me with my browser? Nope. They don't. They don't have any visibility. It's only if your browser drops malware into your downloads directory where, the endpoint protection might pick it up. Other than that, there's not much visibility. And the reason I mention this is you're going to see there's a new host of attacks the attackers can do completely in the browser without having to even drop malware or anything else like that. So secure web gateways can no longer help, and your endpoint protection can no longer help. You're kind of in that kind of gray zone. The browsers are where attackers are starting to target. 1 second. That's what we're going to talk about. I don't want me to build up the suspense, but we're going to see you're almost going to get to the point where there's like an OWASP top 10 for browsers, and I'm going to get into them just 1 second. Two more, just give me 1 more minute of build up for anticipation, and then we'll get into it. Secure web gateways, like I said before, we have web gateways. Basically, all of your tabs from all of the browsers and all of the people in the organization, it goes through a secure web gateway. And the whole point is, again, it blocks bad stuff from coming in and blocks good stuff. It allows only good things, etc. But doesn't really work that way anymore, because the tabs, when you're running applications, they're so contextual that there's just no way a secure web gateway can keep up. I mean, the best it can do is block domains and things like that. But you're going to see in a moment that because of JavaScript and other goodies, everything that the secure web gateways used to do, the attackers are finding ways to circumvent. So let's get to the question. What are they doing? What are they doing? Here's one thing, and this is just a little news article here, but browser-based cybersecurity threats surge as email malware declines. So what it used to be, when you thought of phishing, it was always email attacks, right? And they still do it. I get email texts all the time. Oh, you've got a toll you haven't paid and all that kind of stuff, right? So they used to send a lot of emails, but you're going to see in just a moment that the browser makes an even better delivery vehicle for phishing attacks and other things like that, because it is a mini computer. It is a programmable environment. If you come to my website, I can use JavaScript to do a lot of things to your web browser, which makes it a lot more conducive than even things like phishing. This is very interesting. Palo Alto put out this global incident response report, and it says here that nearly half of security incidents investigated involved malicious activity launched or facilitated through employees' browsers. Yes, sir.
Email that has a link that you click that opens.
Very much, it could be. So it's not like if it's email, it's not browser, browser's not email. Email can still be the vector to come in, but the point is, once you click on that link, now you're depending on your secure web gateway to help protect. And what I'm saying is that's no longer giving you the protection that you think, and now you're getting a lot of the meat of the attack happening in the browser itself. But the point is, we have to agree, the browser plays a pretty important role. If all investigations, 44% of all investigations involved the browser at some point. Clearly, there's something not so good here. And remember, think about how many investigations you might have just on like botnet, like, kind of just random traffic on the internet, but 44% goes through a browser. So clearly the browsers are playing a larger and larger role. So the browsers themselves, like I said, they have their own ecosystem. And one of the things the browser has inside of it, which we're going to talk about quite a bit today, are extensions. Has everybody installed an extension before? Yes. Statistically, 85% of you have, right? So some of you haven't, but most of you have, right? 85% of folks install extensions. What makes up an extension? Does anybody know? It's a program. It's actually, it's like a mini program. It's literally HTML, CSS, JavaScript. That's it. With a manifest.js file you stick in, and that thing can be installed in your browser, and it has superpowers like you wouldn't believe. which we're going to talk about in just a moment. And because it's HTML, JavaScript, and CSS, it also is potentially vulnerable to the same beautiful top 10 or ASVS vulnerabilities that we all know and love. So this was an example of an extension. And again, we're going to get into the security of extensions in just a moment, but this is a little bit different. This was a Cyberhaven. Anybody here from Cyberhaven, by the way? Okay, good. We can talk about them then. So I'm just joking. So Cyberhaven is a security company. They made a security plugin, and this was just a few months ago. This was December 25th. So Christmas Day, 2024. Their admin received this email, and it basically said, hey, your extension is violating some of Google's policies. We're going to kick you out of the Google Play Store. So clearly that put the admin into fight or flight mode, right? And that's where mistakes were made. I'll show you what happened. So basically, going back. This was the email. Again, it was a kind of phishing email that basically said, again, starting with email, but basically saying, hey, we're about to kick your extension out of the store. So the admin missed a couple indicators. Number one, you can see that they actually registered Chrome4extension.com. So it kind of looks legit. Again, if you're freaking out, it's Christmas, you're like, my extension's about to get pulled out. So it looks somewhat official, but clearly it's not from Google. But then again, it's all designed to trick. And then the attacker then goes to, if they would have actually looked at it looks very realistic, saying they're about to kick out. When it says go to policy, you can see here that they actually registered a second domain. And that is, it's kind of hard to see, but it's app.checkpolicy.site. So again, it's kind of making you feel like, okay, this is a policy checking type function of Google. You know what? That admin, to defend that admin, they only see it for like half a second. Because if I play the video from, I'm going to back up a second and we just play it again. The minute it loads that page, that checkpolicy.site forwards them to this page, which is the Google permissions page, because that page basically is, requesting permission to edit the extension, which forwards them to Google. So if the admin clicks on that link, to them, it looks like you see a redirect for like a fraction of a second. Maybe you don't pay attention. And now they're looking at a Google login page. Exactly. So now if they would have clicked on the privacy policy, there was another chance to see that it was a Gmail address. But again, it still looks kind of legit. And by the way, this all happened, right? So they click, and then it says here, the account that the bad guys made on Google was called Privacy Policy Extension. So again, it's not like Bill wants to take over your Google account. It is Privacy Policy Extension wants to access your Google account. And it says here that, would you like to allow them to do this so they can see, edit, update, or publish to the Chrome Web Store? So the admin clicked continue, and what happened? That the bad guys now had access to publish whatever they wanted to that store. And because you can go to the Google Chrome store and download any extension, because like I said, it's just HTML, CSS, and JavaScript, they had pre-downloaded it, they had added in some malicious code. So the second they got permission to do this, then they pushed their evil extension, which was the normal extension with a few extra goodies. And then what happened then? They overwrote the existing extension, but the worst part is the minute you upload a new version, the Chrome store.
It's variation of the
Well, it's a variation. A lot of people. Oh, SolarWinds. Yeah, exactly. This was like a mini SolarWinds because these guys had, I believe, 500,000 customers. So with a blink of an eye, the bad guys were able to put malicious JavaScript with superpowers, not normal JavaScript. This is malicious JavaScript that has access to the entire extensions API out to 500,000 people's machines on Christmas Day, just a few months ago. So that's not something that we normally talk about at OWASP, but it is definitely part of the ecosystem where we live. Because if your browser is not secure, how can anything be secure, right? Absolutely. So the web, like I said, a web browser used to be very simple. It would just show HTML, CSS, JavaScript. Now the web browser itself has a bunch of API calls you can make. So you know that you can go to like zoom.com and it'll ask you, hey, this website wants to access your camera and microphone. So in that case, that web application is making use of the API calls to the browser itself in order to initiate that. And extensions have a different set of APIs that they can access as well. So those are APIs of the browser. Yep. So far, so bad. All right, let's keep going. Yep. Well, we're just getting started. So yeah. Well, apparently one at least. Yeah. Yeah. But I like your question. Your question, I mean, you're basically saying, hey, but the browser, that was a browser-based attack, but it was still caused by human error. But what I'm saying is that could be true from that administrator and maybe, whatever. But also the fact that you've got people within your environment that have web browsers that have installed extensions. So that's where some of that risk comes in that most organizations might not be aware of. You've got your browser, you've got thousands of people in your company, tens of thousands, hundreds of thousands, depending on your company. And now you've got browser extensions in your environment that are causing risk that you're not aware of and nobody's doing anything about, right? So that's, again, we're just getting started with browser security, but that's just that one piece. So to your point, let's do a very down and dirty, rough risk assessment of the browser attack surface. So I'm going to ask it this way. You're a hacker, right? You've all become, hackers for the moment. What would you start looking at if you're going to attack a browser? What would be the things, those key areas that you would want to start investigating? Yeah, go ahead, shout it out. Let's just say it's okay. Let's say it's a modern browser, any one of the big four.
Variation of the initial attack vector.
Okay.
Was get in the way of any OAuth.
Yep. Yep.
Field credentials at the keyboard.
I love it. So the browser itself is normally authenticated into, and if you're using Chrome, it's authenticated into Google and so forth. So if you can get into that OAuth flow, there are some shenanigans that you can play. That's true. Also, yes, go ahead. Absolutely. So extensions in general are a train wreck of badness. So yeah, extensions, authentication. And remember, we talked also that there's this API within the browser where you can turn on microphones and cameras and geolocations and things like that. That's a possibility. The fact that the browser can do an overlay on any part of the DOM. I mean, that's just how they work, right? Some extensions also put overlays into the DOM. So there's some shenanigans that can go on there. So the list, this is just, some basic stuff, but, with the browser, you can look at the fact that there's the user elements. So there's all sorts of things you can put onto the screen itself. Browser features, you've got WASM. If you're not familiar with WASM, it's WebAssembly. It's essentially a binary format that you can send to a browser and it runs in the browser itself. CORS misfigurations, which we all know about, HTML5 API, which we talked about a second ago. Extensions are, again, pretty bad. File features. Some of you may know, some of you might not know that JavaScript, modern JavaScript, has file creation capabilities on the client. So remember we talked about secure web gateways. And secure web gateways are supposed to block malware files from being downloaded. But I can use JavaScript on the client side to create files directly and basically prompt you to download them. Session attacks, configuration attacks, and then network attacks. When we talk about extensions, the extensions actually have certain set of API calls that they can make that they can actually interfere with a file upload or file download data stream. So they can inject malware. Let's say you're uploading a Word document to your file share. An extension can get in there and put in malicious macros and upload them. Or when you're downloading a PDF, it can put in malicious stuff there and download that because it can access those streams. Yes, sir. Yep. Weak settings. Yeah. So this is a great point. Browsers, they're kind of meant for like the general audience. They're not really designed for an enterprise security environment. And that's exactly right. The default out-of-the-box configuration settings are weak. There we go. There we go. There's probably not many people in the world that do that, but so real quickly, just to kind of give you an understanding of what browsers now can do, there's a whole new set of protocols that they have access to, which generally do not go through a web application firewall, which means the attackers can do things like WebRTC, WebSockets, gRPC to talk directly to the browser without any kind of security control at all, intermediating the conversation. Does that sound good? No, it doesn't. It sounds horrible, right? We would never want something like that, but that's what's going on. And so again, it's not just your old, I hate to even bring, maybe, I want to say OWASP Zap. I know it's not OWASP Zap anymore, but Zap, right? It's not like the old days you just pull out Zap and you can look at the HTML streams back and forth and then figure out what data is going back and forth. There's all sorts of other communication channels now that are normally invisible, that are not really invisible, but they're often overlooked. Right? There's also WebTorrent and Firebase cloud messaging, et cetera, et cetera. The whole point is it's not your daddy's browser anymore, right? Browsers are way more complicated and complex than they used to be. So, and again, this is just a little illustration of the fact that they're all unmonitored. These channels, for the most part, are not being looked at. They're not being monitored. They're not HTTP. They are binary in nature, and they allow the attackers to talk directly to web browsers. So, browser phishing. Why is the browser now so appealing to phishers? Well, let's think about your traditional phish, right? Your traditional phish is the bad guys send you an email, and it says, what? Do you guys have a favorite phishing email? What's your favorite phishing email? If you were going to write a phishing email to somebody, what would you send? Toll road, right? You've gone over a toll road, click here to pay the fine, right? They click, it takes them to a website where they try to harvest your credentials. Secure web gateways are good at blocking that kind of stuff, right? Because they're very easy to tell. They actually will go out there, they'll grab the content of that file, they'll say, this looks bogus, and they'll block you from connecting to it. You'll get a message saying, this website is restricted by your company's policy, right? But think about how that works. First of all, there's like a known set of bad domains. Fine, that's legitimate. That's fine for the secure web gateway. But they also go out there and they look to see what the content of the page is. Now, remember what I said before. If I've got JavaScript, if I've got WASM, if I've got all these new technologies, I can set up a web page that looks totally innocuous. Like here's a wiki page on something really basic. So the secure web gateway is like, looks good to me, lets it through, and now I can use JavaScript or WASM or something else to completely rewrite the page once it hits the web browser. So it makes it, again, very, very hard for secure web gateways to block phishing. That's why you're seeing this exponential rise in browser-based phishing attacks. Because again, the bad guys can control the DOM, which means they can control the browser content, which means they can make it look one way when it's being checked by a security control and a different way when it lands in the browser. So far, so good? Good. Good. They also are doing something also a little bit interesting. It used to be we could have like a list of prohibited domains, right? You register like, something really bad, right? Whatever. By the way, you guys know like the .top domain for whatever reason seems to be very very popular amongst hackers. It used to be like the .us domain and things like that, but whatever. You can block all those bad domains. But now the bad guys are doing something a bit different. They're opening up accounts on Google Site or SharePoint Online or things like that, and they're doing their evil stuff there. And now it's almost impossible to block because you're looking at the domain, you're like, well, it's google.com, it's microsoft.com, it's got to be safe. And those secure web gateways are letting that traffic through. And what will happen is when you land on that kind of malicious SharePoint site, there's links from there to other bad places. And the secure web gateways allow it because it came from a secure origin, which would be SharePoint Online, as an example. This is kind of funny. Has anybody heard of this? All right. It happened to one of your users. All right. So we got to stop this. So let me explain what this is. Remember we talked about the web browser has an API. So JavaScript can talk to the web browser and manipulate the web browser. Well, one of the things you can do is you can request to read and write to the user's clipboard. Is that safe or not safe? I mean, it's kind of handy if I go to like github.com and I can say click copy to clipboard. That's nice, right? But it can be malicious when the attackers do this. So what they do is they say, hey, prove you're human. And this is, by the way, this was just reported on krebsonsecurity.com a couple days ago. Click here to prove you're human. All right, to verify, hit Windows R, press Control V and press Enter. What happens? What does Windows R do? It's a run command. It opens up a command prompt. Control V pastes. And what did the bad guys do? They preloaded your clipboard buffer with all sorts of bad commands. So you hit Control V, you've now pasted all those bad commands into your prompt, and you hit Enter. You've just hacked yourself, right? The attacker used your clipboard as a vehicle. I know it's kind of funny, but they used your clipboard as the vehicle to get over all sorts of bad commands. And for a normal user, now I know nobody in this room would fall for this, but you got to think, if you have a giant company, there are going to be people that will fall for this, and they are falling for this. Question. So it's just JavaScript. You can request clipboard access through JavaScript. That's that web browser API. Right? The same way you could say, turn on the camera, turn on the microphone. Yeah, I mean, of course, you have to request permission. And some browsers will actually say, this website's trying to copy to your clipboard, but most don't. They just let you copy to clipboard, right? In fact, that might even be what this is. You click here, I'm not a robot. What it's doing is it's probably using clickjacking to get you to kind of just, yeah. Exactly. There's no verification to copy on the clipboard, which is why, again, my point is browsers are not really enterprise ready when it comes to security because of stuff like this. Right? Yeah, because it's an active user experience. If I go to someplace where it says copy these commands to the clipboard, which is legitimate. You go to github.com, you can say copy clipboard. Imagine if then the browser's like, GitHub.com is trying to copy to your clipboard. Do you want to allow it to do it? Just kind of ruins the whole workflow, right? So that's why they try to, they sacrifice security for usability. I'm not calling out the browsers. I'm just saying this is what's going on. And these are the kind of things that are happening. And just so you know, this was also from Krebs on security. They got many versions of this. Here's a Google Chrome version. It makes you feel like the Google Chrome environment is telling you this, or Facebook is telling you this, or whatever. This is only using HTML, right, and CSS. So you don't even need cross-site scripting. If you can do some kind of HTML injection on a web page, an attacker could put this on a legitimate web page. And then, well, I guess they would need the JavaScript to write to the clipboard. But nevertheless, you can see that it's becoming a very popular attack. Extensions. Again, extensions are really that zombie apocalypse of the browser world, right? Extensions extend, obviously, the capabilities of the web browser. They're very privileged. They are very privileged. They can do all sorts of crazy stuff. There is minimal checks. Well, actually, before I give it away, do you think there's extensive security checks to put an extension into the web store? No. It's basically you upload it, right? So there's minimal checks. There has been some improvement. So this manifest version 2 to manifest version 3, it did restrict some of the more egregious security problems. So in other words, version 2 is from 2011. It was really permissive. And then just recently to that version 3 restricted it, which sounds good, except for the fact that some browsers do not force extensions to conform to version 3. So not calling anybody out, but Firefox still allows version 2 extensions to be uploaded to their web store. Chrome also allows it, but it gives you a warning, and Safari does not allow it. It's like, no, you're going to be version 3 or nothing. And I'm not sure about Edge. So what are some capabilities? I mean, we could do a 2-day training class in just security of extensions. It's a big topic, but here's just some goodies. Read and modify every web page. So when you install an extension, it'll give you like a little bullet point saying, is it okay if I read and modify every web page? So for example, Google Translate, it needs that ability to read and change the DOM in order to do the translation, right, etc. A lot of extensions have this capability. Exfiltrate data silently. It can take data and it can make a connection out to a remote server. Inject malicious code into uploads, downloads. I already talked about that one. Modify DOM elements, act on behalf of the user session. So it's kind of like CSRF built in. And then modifier, this is pretty interesting. It can modify, disable, and re-enable other extensions. So take some of that together and let's get creative. What would you do? If somebody installed your malicious extension, we're going to talk about it. First of all, let's get to that second point, which was how extensive is it? Is there a vetting process to get into like these stores? Well, this is directly from support.google.com. Sometimes you go to the store and there's like a featured badge. Like, oh, it's featured. All right, I guess was selected out of for distinction. This feature badge just means, all right, they followed our technical best practices. So the bad guys can also follow the best practices and become featured. Also, an established publisher. Wow, there must have been an extensive background check. No, it's just the publisher's identifier has been verified. It normally means they did an email verification, or so there might be something else, but obviously they're dealing on a gigantic scale. It's very minimal. So my point is, the badges don't mean much in the web store. Before we even talk about building your own, I'll just mention some attackers, they're just going to look at what popular extensions exist and they buy them. So this was an example of something called the Great Suspender. So the Great Suspender was an extremely popular extension, where it would basically, if you have certain tabs that you weren't using, it would allow you to kind of deallocate some memory so it wouldn't be such a memory hog. So a lot of people liked it because it would make their machine run faster. It was a free extension. It was widely installed. The bad guys came and bought it with a user base of 2 million, and then just simply modified the code, pushed it out, and now had instant malware on 2 million machines. Now that's efficient hacking, right? Like that's not bad. Now, of course, ultimately, I think they were a little bit too rambunctious with what they were doing. They got, caught and they were, kicked out of the store. But the point is, it was a while before, Google caught on. And my question would be, are there other extensions that maybe the bad guys were a little bit less rambunctious that are pilfering your data that you don't know about? Here's another one. So this was GitLab. They found 16 more Chrome extensions that were legitimate, that were found to be poisoned, impacting 3.2 million users. And that was the day before Valentine's Day, just a few months ago. So let's take some of these ingredients and make a recipe. I mentioned that some extensions can turn on and off other extensions, right? Extensions can also overlay onto the DOM. They can put messages up of whatever they want. That's the other ingredient. And the last ingredient is they can dynamically change their icon up in the tray. So take those raw ingredients and let's make an evil cake, right? So I'm going to show you what this is, and this is research from where I work, which is SquareX, and this is called polymorphic extensions. So the video is a little bit long, but you're going to see that basically, hang on a second. What am I doing? Of course, yeah, please.
Extension. If they're the same.
Mm-hmm.
If not paid, so same. It seems to me that they still can
Activate or do something. That, maybe we should do some research together, because that sounds, I wouldn't doubt if they can at least get updated.
well can advertise.
Continuing blocking. Interesting.
No,
Okay. Jeff, note to self, we got to investigate that. That sounds pretty interesting. That's news to me. I'm going to look that up. That's pretty cool. Let's. All right, you're going to be in my next white paper. That sounds good to me. So, in this case, in this example, the user, and this is not picking on 1Password in any way, shape, or form. They're a great plugin extension. But this user, this victim, has 1Password, the password manager, installed. So far, so good? All right, just like millions of other people do. I think so, but this attack is not a representative of that. So the user now, so they've got 1Password installed. You can see it up there. You can also see if you hover over it, it says 1Password, right? Got the 1Password icon, which is the number 1 with a little circle around it. Life is good. It's good until this victim user decides to look up a new extension called AI marketing. Kind of popular these days. You want an AI for everything. So they look at AI marketing, and we've kind of blurred it out because we don't, for whatever reason, but they find one, and so the details are blurred out here to protect the innocent, but there's the add to Chrome button, right, which is all it takes. And normally, in most companies, the users have the capability to install extensions onto their browser. So this user clicks add to Chrome, get that little circle, and then it's going to say, boom, it's installed. So now the victim has installed this malicious plugin. That's the only part that's blurred out. So now what happens, I guess there's a little bit more blurred out, the name of this. So the bad extension is this kind of upward pointing arrow. It says a simple extension that helps you automate your marketing tasks. Great. So now this victim has installed this malicious plugin. What is this malicious plugin going to do? This malicious plugin is only requesting 2 permissions. And they don't even look that scary. Read your browsing history and manage your apps, extensions, and themes. Manage your extensions, but it's only 2, just 2 extensions. I would click on yes. It doesn't sound that bad, right? But that's the key. And that's what I'm saying. Imagine the browser is something in the hands of every single person in the world, right? Everybody in your company has a web browser, probably multiple. And these are the security decisions that they're making. So this one says here, manage your apps, extensions, and themes. It looks very tiny. It doesn't look egregious of like 100 different things. So the user accepts. So life seems good. They pin it to the, this is kind of the tricky part. Take a look here. They've now pinned it to the that little tray. So you can see here that you've got this extension with that little arrow pointing up. That's the malicious one. You've got 1Password here. So what's going to happen? Well, this malicious extension has a trigger in it. The trigger is this. The minute you go to a website that it's interested in this case, well, yeah, there's a lot of things it can do. Here's what it's going to do. The person is now logged. They've gone to Salesforce.com. Again, this has nothing to do with Salesforce. It's just an example. Hang on a second. Whoops. Hang on. One sec. What? No. It all happens so quick. 1 second. All right. Have you guys ever seen a movie? Oh, no. My gosh. Sorry. This is really, the video controls sometimes are very hard to get just right. Okay. Have you guys ever seen a movie where, like, somebody's kind of breaking into a building and there's like a guard and they come up behind the guard and the guard passes out and they put the guard's clothes on and then they kind of go, that's what this is going to do. So the extension, you're going to see in just a second, the minute that we navigate to Salesforce, this malicious extension is going to turn off 1Password. And then it's going to change its icon to become 1Password. So it happened. It happened so quickly you don't even see it. And now that little extension up there, the evil one, changed its icon. And then it's going to have a message to the user. Oh, by the way, you've just been logged out. So the user's like, what happened? Oh, I got logged out for some reason. Okay. It's kind of weird, but whatever. I guess things happen. So let's kind of do a replay here real quickly. Did you see that extension get kind of knocked over the head? See, there it is. And boom, it's gone. Now that malicious icon, boom, it changes its icon. And it even changes its hover over, right? The tooltip text. Whoops. 1 sec. Sorry. There's like overlays on the screen from Zoom. So even when you do the tooltip text, it says 1Password has access to the site because that name is also mutable and changeable at any time by the extension. So the extension now just changed its icon, changed its tooltip text, and it's displaying a message. So now the victim clicks on it, and because it can control the DOM, this malicious extension puts an overlay, which is an exact replica of the login of 1Password. So the victim puts in their credentials, which are then what? Sent to the bad guys, because the extensions can create network connections out to any server that they want. And then, sorry, last thing, sorry to yell, I'm getting excited. Then, once the deed has been done, the malicious extension re-enables 1Password. 1Password then fills in the login page, and the user thinks, oh, I just re-authenticated into 1Password. All is good. They don't even realize there's nothing that breaks their normal user flow.
That's good.
That's a fun one. I guess it's kind of like, giving the chance to like. This case, I think you're right. So MFA would definitely block this, but if you look at this, and I don't use 1Password, but there is this secret key along with a password. So I think if you put in, I think it is asking for MFA, and correct me if I'm wrong, but it is asking for it looks like it's 2-factor right here, and both factors being sent out. So the bad guy could take that and immediately log into your 1Password account. They wouldn't be able to log in again, but you go in there once, grab all your passwords, unless everything had an MFA, correct? But this is just an example. We could probably this is just picking on 1Password, but there's probably a million different variations that bad guys could use for. Yes, in this example, right, the attackers are exactly, they're targeting 1Password to get the passwords to all their things, but they might be able to do this to get your email, to get access to internal websites, document stores, et cetera, et cetera. Or just prompt you for that second factor, send it back to themselves, and immediately automate the login to that next, that target website. Very good. How much time do we have left, by the way? I'm good. All right. I'm going to keep going. All right. So file side creation. This is again just showing the power of modern JavaScript. What is this 10-line of code? What does it look like it's doing? It's creating a hello world document, but the trick is it's creating a hello.txt, and take a look at what it's doing is it's got this message, hello world. It creates a blob of data, text plain. It then creates this object. It then creates a link. It creates a URL. It then creates this download file, which contains this text. And then the JavaScript now clicks on the link. So if you go to this website, this is just proof that you would pop into my website and immediately your browser will try to download this generated file on the client side, hello.txt. It doesn't mean that you still have to click download or save or whatever, but you all of a sudden you're seeing this download. There's a million ways you could put this into a tricky situation, right? The bad guys could do this. And the point is, this is how, again, my point that secure web gateways can't block the malware from coming in if you can create malware on the client side using JavaScript. And then, of course, this is just the classic, browsers also have 0 days. And when they have 0 days, it's a really, really bad situation. This happened to be Google. This was just a couple months ago or a year ago, but there was a big vulnerability inside of their V8 JavaScript engine, which affected they have an install base of 2 billion, right? So it's, when it comes to patching that, it's a really, really big deal. And that was just kind of like the final note in what we've got to worry about when it comes to browsers. So what do we do? You're like, okay, Jerry, great. Now you told me all this crazy stuff about browsers. I'm not going to be able to sleep tonight. What do we do? I don't know. I'm just letting you know that these things exist. I'm saying that we are the OWASP community. We are all about promoting message of secure, application security, and the browser is an application. So it makes sense that I would come here to talk about this kind of stuff. I say that, we really have to, as a community, help to kind of educate people about these various attacks, about extensions, browser risks. I'm going to be doing what I can to see if we can get this kind of browser stuff into the overall discussion of OWASP. If you're in an enterprise, there are obviously detection and response functions that can be put into the browser. That's kind of what we do. Guidance on building browser extensions, and I think OWASP can really help lead the charge in this emerging domain to help protect people around the world. Ladies and gentlemen, that's my entire presentation. Thank you. So we have time for questions or, okay. Questions, comments, concerns, complaints? Anything? Yes, sir. Exactly. Yeah. So we essentially, what we do is we create extension that goes into the browser that makes sure that you've got full visibility so that people in the SOC or whatever else can be monitoring the browser of all the browsers, no matter what type it is in your organization. And if anybody wants to talk about this, about your company, talk to Jeff or email me. We're happy to have a private session like this just for you guys. Like if you're at whatever company you're at, just ping me and we can do like a Zoom call where we kind of go through this in your environment and talk about the risks. Good. Yeah, by the way, again, this is the benefit of being an OWASP member. I got Jerry at owasp.org. You can email me anytime, or Jerry at sqrx.com. Yeah, this is a really long time ago, so I was like one of the few that got just like the one name. Oh, did they? Okay, don't tell anybody. Right? I still have mine for now. Cool. Any other questions, comments, or thoughts? All right, well, Jeff, I'm sorry, go ahead. Yes. The way that we solve this problem is we put an extension into the browser that essentially instruments the entire browser. So anything that happens in the browser, we're able to do our security without sending any data back to our servers. So we can help monitor the browser, block, we can see what's going on in the browser, block, these kind of client-side downloads or client-side file creation and all the other stuff that we talked about. Everything we talked about, we can help solve. It's called browser detection and response. So just like you've got EDR, which is endpoint detection and response, or XDR, extended, this is browser detection and response, BDR. Yes, sir. Yes. Well, again, I mean, just put it in the context of what we just talked about, right? So that's probably one that we should talk about offline, but that could be another white paper. So yeah, very good. Well, I know probably a lot of you are chomping at the bit to take off, but I'll stick around if there's any other questions. If you want a demo or anything else like that, Jeff's there. We also have comic books that we brought and stickers, so you're welcome to take those. And again, thank you all very, very much. Okay. All right.
Thank you so much.
I appreciate it. Thank you.
So now we have our sponsor, so to